Okay, please note, always, 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 the outer integral must have constants as endpoints. The inner integral can have endpoints which are constants, or they can have functions which are in terms of the outer variable. So sometimes setting up a dx dy is easier than setting up a dy dx. Often, evaluating the other is easier. I don't know if often is always the right word, but sometimes it's a matter of which integral is easier to set up. Sometimes it's a matter of which integral is easier to do. Sometimes it's a matter of, like what we saw, do you have to set up a sum of two double integrals, or is it just a single double? So is it just one double integral? Like, how many terms are there? So let's set up the integral of x cubed y over the region R, where R is enclosed by a parabola and a line. So just for a quick picture of this, okay, here it is. There's the parabola y equals x squared. There's a line y equals x plus 2. And one thing we can do is we can describe the region as saying y is stuck between x squared and x plus 2 for x between negative 1 and 2. If we go back and look, there's x equals negative 1, there's x equals 2, and we're looking at the region in between. And so that's this region right here, and we'd set this up, as, let's see, so y has to be stuck between, for the lower y values, x squared, the parabola, for the upper y values, x plus 2 on the line. Right, so we could do that and set up an integral that looks like this. So x, the outside integral has to have the constants. So since the y is bounded by functions, so the outer integral, let's see, dx here, negative 1 to 2. So dx is the outer differential, and the integral sign says negative 1 to 2. Dy goes from x squared to x plus 2. Okay, so that works, but we can also describe R the following way. So R can be described by the union of two regions, and that's what, so look at this region that's shaded green here. Instead, we could create this as two separate regions. Yeah, so this could, see here that there's this region down here, this purple region, but you see that this purple region, it's bound on the right by the parabola and on the left by the parabola, and then all of a sudden that changes. See, and in this blue region, it's bound on the right by the parabola and on the left by the line. So we have to be a little more careful, yeah? So you'll notice if you solve for x in y equals x squared, you have plus or minus root y, and so on the bigger side, x is bound by positive root y. On the negative side, on the smaller x values, bound by negative root y. And in this region, y goes from 0 to 1. And in this other region, y goes from 1 to 4, I guess it is here. Yeah, 1 to 4. And on the smaller side, x is bound by y minus 2. And for the bigger x values over to the right, x is bound by root y. So there's these two separate regions that are summarized here, and we'd have to set up these two separate integrals to do a dx dy. Yeah, there's a dx dy, y going from 0 to 1, x going from negative root y to positive root y. And then the other integral for y values from 1 to 4. Now you'll notice the upper x endpoint is still a root y, because on the right edge, the bigger x values, it's always by the parabola. But you'll notice on the left edge, it was the parabola before, now it's the line. So we had to solve for x in this y equals x plus 2, so x is equal to y minus 2, and that's what is down here. So it's just a matter, I guess, of which is easier. Would you rather do this would you rather do this one double integral, or would you rather work on the sum of two separate double integrals?